Good afternoon, everyone. Just want to make sure everyone can hear me okay. Looks like the mic's working good. Okay.
Yes.
All right. So I'm going to start out with talking about the Galaxy project, the main project, which is at usegalaxy.org. And this is a public Galaxy instance. It's on jobs that are submitted to this Galaxy or run on multiple computers, but there is sometimes they get very busy and there could be a long waiting queue. There's a lot of tools available on the Galaxy website, and there's even more available in their tool shed. And we'll go over how to look for tools later. Good thing about Galaxy is it uses a browser, so you can use Firefox. There have been some issues with Chrome with some tools, but your best bet is to use Firefox. And it's a GUI interface, and all your files are saved. And as far as the Galaxy project, if you go to usegalaxy.org, the files are saved on their servers. I'll also show you our Galaxy instance, which is called Maroon Galaxy, and that uses the Grace cluster. And so all the files for Maroon Galaxy are saved on the Grace cluster. So if you want to use our Maroon Galaxy, first try out usegalaxy.org, see how it works. And there's a lot of tutorials available, and make sure it's good fit for your project. Some software may not be available. There may not be tools for what you want to use. So there's a lot of tutorials if you go to galaxyproject.org/learn, and you can work and you can browse through there and see a lot of these have sample data sets you can upload to your Galaxy, whether you're on usegalaxy.org or whether you're on Maroon Galaxy. They'll have URL links you can paste and upload the data for the tutorials. There's a lot of videos. You can see right now there's 154 videos in the Galaxy project page here. A lot of them are maybe simple videos lasting a few minutes on just how to upload a file. Some of them are actually presentations at conferences or various events. All right, so if you want to follow along with the exercise, you can apply for an account at usegalaxy.org. It's very quick. You just fill out the form, and as soon as you click create, you'll pretty much get an email in less than a minute, and check your email, and you'll want to confirm your registration. So this is go to usegalaxy.org and click the login or register page or link. It'll take you to the login page. So then you'll come at the bottom and click register here. Then fill out this information, and when you create your account, it'll send you an email. So we'll give you just a few minutes to do that. Okay, you don't have to register, to use some of these tools, but for some of the tools that take a long time, like an assembly tool or an annotation tool, you'll have to register because those take a long time. So if you don't log in and if you just start using Galaxy now, it will save your data sets for I think a few weeks, and then they'll be deleted since it's using an anonymous account, and it might be only local to the computer you're working on. So register for an account so you can save your results for a while and come back to it later. So this is the basic interface here. On the left, we have the tool panel. These are categories here, and you can open these and find a lot of tools inside of those. Best approach is just to search for the tool you want to use. And then you can see anything that has bow tie in the tool name or related to bow tie will show up. So once you find the tool you want to use, you can click on the tool, and then it has the information for you to fill out in this middle panel, all the options for the tools. So a lot of this, basically on the back end, you have a tool that was built for the Unix platform to run on the command line. And this is just a GUI interface to use that command line tool. So the options are here in the middle, and then you set all the parameters, select your input files. And in this case, it's saying you don't have any files in the proper format for this tool. And then when you come down here, all you need to do is click execute, and then that will run the tool. There's some information down here at the bottom. It's like the help file, the usage information. And then on the right panel, you have the history for this. You can name your histories. You can have multiple histories. You can have multiple histories if you log in. So I'm going to go ahead and log in. All right, so now this is my account. I have an unnamed history here. And so what we want to accomplish today is want to learn how to use the Galaxy training tutorials. We'll go through one of those so you can get familiar on using the tutorials. Uploading and downloading data, searching for tools. We've already done that. Certain tools have multiple versions. So you may want to select, if you ran a tool with an older version, you may want to select an older version because the default is to use the newest version. Viewing the data, different ways to view the data, resizing windows, you could see the data better, changing file attributes, debugging jobs, creating new histories, copying data sets between histories. And there is also a feature called workflows. So basically it's kind of like a flow chart of all your tools linked together. Once you have your history of a project complete, then you can save it as a workflow, and then you can just save the workflow, and then you can run the workflow in a new history with new data input files, and just select the input files and then run the workflow. That way you don't have to piece together all the tools again. And we'll show you how to permanently delete files to free up disk space. All right, so what we're going to do, log into your account, your usegalaxy.org account, or if you already have a Maroon Galaxy account, you can also go there. So we're going to select this little graduation hat. That will bring up the tutorials. And then we're going to click on assembly. And then scroll down. You can see they've got several here. The one we're going to do today is Unicycler assembly. So this is just a link to the slides. We're going to follow the tutorial. So click that. All right, so this is just a self-guided tutorial, and pretty much I'll work through one of these and then you'll get an idea of how to work through all the other tutorials. So it shows you your the question you'll have to do this type of analysis, some of your objectives and some of the requirements. Introductory to Galaxy analysis. You can run these tutorials later, but basically these are kind of integrated into what we're going to do today. Estimated time is 4 hours. That's basically runtime. It's not going to take you 4 hours to click and configure everything, but I have seen it complete quicker. But the thing about it is, you can select one tool, you can click run, and your job is submitted to a queue, and then your job might be queued for an hour until resources become available. Then it might take another 3 hours to run, but you don't have to wait until that's complete before you go to the next step. So you can go to the next step, click a new tool, select the output from the tool that hasn't run yet, and basically build your workflow and keep working, building your workflow, even though the job may still be on the first step. And that's what we'll do today. So there's some background on this tutorial. It's using E. coli as the model organism. And there's some background here. This tutorial uses short reads, 250 base pair paired in reads, and it uses Oxford Nanopore reads, the long reads. So here's a graph of the size distribution of the Oxford Nanopore reads. You can see the average might be up somewhere here into 8,000, and some are up into 15,000 and longer. And then there's some information on how the assembly is done with Unicycler. Unicycler's built for bacterial genomes, and the bacterial genome is a circular chromosome, kind of where the name comes from, Unicycler. And there's a spades. Spades is also used by Unicycler, and it talks about what part of spades is used. More details on how it's used. There's also a step within Unicycler that uses pylon, and that this part describes how pylon is used to improve the genome assembly. And then the next part after the assembly is the annotation. So by annotation, I mean that once you have your assembly, it's a de novo assembly, and you don't know where any of the genes are located. So basically you take known genes and you align it to the assembly to identify where these genes are located on your de novo assembly. So, yes. The jobs are at usegalaxy.org. It's still executed on, the jobs are run on the usegalaxy.org computers. So it is run on servers that's maintained by the UseGalaxy team. So basically, whether you're running as anonymous or as a logged in user, you're going to be using the same resources. If you're logged in to Maroon Galaxy, you'll be using the Grace cluster, and the queue time may be shorter at times, but in the past, historically, usegalaxy.org can have pretty long queue times. All right, so the first part is to load data and look at the quality. So first step here, hands-on part, is to make sure you have an empty analysis and give it a name. So this plus here means you can, if you're not sure on how to create a new history and give it a name, you can click this plus and it tells you how to create a new history. All right, so click the plus icon at the top of the history panel, and then click the gear icon. If the plus is missing, you click the gear icon. So let's go. So now this little window here, this is the tutorial window. So now we're going to click outside the tutorial window back on the browser. This takes us to the browser. You can see the plus is here. So you can click that and it'll create a new history. I've already got a new history here, but I'll just create a new one to show you what it looks like. Basically, creates a new history. Now, to get back to the tutorial where we left off, just click the hat again. And then the next part 2 is to import the data from these websites. So you can copy that. And if you're not sure on how to import, the next box, you can expand that and it'll show you how to do that. So the way you do that is, you can see I copied these 3 links. I'm going to go back to Galaxy, click upload data, paste or fetch data. And then right here, I'm going to paste. So now I'm going to click start. You can see it's got my 2 Illumina files, the forward and reverse reads, and then it's got the ONT min-on data. So click start, shows you it's adding to history, and then that's basically running now. So you can close this. So depending on how busy the server is, it could take a while. So now grade means it's queued. So your job is queued. So now it needs to free up some resources before it's running. Now it's running. It's going to be in this state as long as it's running. If you run an analysis and it takes 3 days, you'll see it as in this yellow state for 3 days. And then when it's complete, it'll be green. All right, let's go back to the tutorial. It's talking about data libraries. There's not a data library for this data set, but in case there is, you can go to a data library. We do have some data libraries on Maroon Galaxy, and we'll talk about that later. But we don't have this data set because it's easy enough just to copy and paste this using the tutorial. So you can see this is an example of various histories. The green histories here are completed jobs. Yellow here is the running job, and gray history means it's queued. Hasn't started running yet. So at any time you can delete any of these histories, whether it's finished, whether it's running, or whether it's queued. There's an X right there, each one of those. All right, so even though it's still running, we can go ahead and do the next step. We want to look at the read quality. So we're going to search for the tool FastQC and select all 3 FastQ data sets. So FastQC. And then you can see right here, it says there's no data sets available. Looks like we have to wait just a bit before these data sets get assigned the attribute for what type of data set it is. So while that's running, what we're going to do is we're going to run FastQC, and then we're going to run multi-QC. So multi-QC creates a graph of all your data sets, the output from FastQC into one graph. That way you don't have to keep moving from graph to graph for each of your data sets. So FastQC is going to create three quality output files. You're going to take those 3 quality output files and put them in multi-QC, and it'll create a single graph. So here's what FastQC looks like. Actually, this is a multi-QC output. So
can you please go back from FastQC? What did you select?
I haven't selected anything yet because it's still, okay, now it's done. So now let's click FastQC again. Refresh that. Okay, now it finally updated the attributes. So now it shows the files are in FastQ Sanger. So whenever I select FastQC, now I'm able to select the files that were uploaded. So let's go back to the tutorial, and then, so the next step is FastQC. We want to select all 3 data sets to run at once. So right now it looks like you can only select one, okay? So the way to select multiple is to click this button here, multiple data sets. Now I'm able to select all 3 or select the ones that I want. And the way you select multiple is to hold the control button down. Accept in Mac. What is Mac for control? That was command. Okay. So control and click all 3 of those. So you select all 3. If you have a Mac, you hold the command button down and select all 3 of those. What does the tutorial say? It basically says just select all 3 and run. Okay. So you don't need to change any of the default options. So we're just going to run that. Okay. So let's look at the history panel here. You can see the first data sets running now, they're all running. And there's also these handy little resizing buttons here. So you can increase the panel on the history panel so that you're able to read more of the details here. Okay, or you can collapse it all together if you want. So basically, you can take a peek at the data by clicking this. It will show you the first chunk of data, and you can see the reads here. It's FastQ format. And right now, it's not assigned to any database. The database would actually be the genome build. If you click here and you do have the genome build, you can find the genome build here. We don't need to do that right now. We'll just keep going along with the tutorial. So now, I'm going to refresh the browser or something. So I got to come back down here. Okay, so we run FastQC. Now we're going to multi-QC. Multi-QC, multi-QC runs different types of, it can run on different types of, it can run on the output of different types of tools. In this case, the output is from FastQC, and we want to select raw data. So it looks like FastQC actually finished pretty quick. So let's look at one of these files. This is the raw data. So each sample produced 2 data files. You can see for data set 3 is the MinION data. So for data set 3, you got 2 files. The first file, so the first file is the raw data file. It's a text format, and you can view what it is. It's just showing you in text format the analysis. The actual web page for FastQC is the next file. So you can browse this and see the basic statistics, per quality, sequence quality, per base sequence quality. Now, this is MinION data, so the quality is not the same as the Illumina data. So that's why you see the quality way down here in the red. So, and that's why you see 3 failed tests here. And you can just see based on this Fred scale here, quality scores. If we were to look at the one for Illumina, the Illumina data is going to look a lot better. Look at this web page for Illumina. Click on View, and you can see it's mostly all up in the green. There is some towards the end here. These are pretty long reads. I think there are 250 bases. Yeah, 250 bases. So as the reads get longer, the quality starts to go down, and depending on the type of analysis you do, you may want to trim, run a trim tool that would trim some of this lower quality off the ends here.
So how you read the quality report on the left hand side, like under summary, different.
How do you read this quality?
Like in the under the summary, like different subheadings, like basic statistics, part based sequence quality. How you decide on those?
So these are basically decided on the tool itself, FastQC. So just because it's failed doesn't necessarily mean it's bad quality and you should throw it out. There may be a reason for it. In some cases, you may have let's see. So in some cases you may have something like this. Ideal graph would be to have all the GC&AT percent. This is a percent GCAT. The ideal graph would have all of them to be a straight line. But here at the beginning, you see this, and in some cases, it's even worse. It looks worse, but you have to know also how the library was created. In some cases, the library was sheared. The DNA was sheared using a transposase, and the transposase would cleave the DNA in a certain motif, and you'll see this motif right here, and it makes the tool fail. So you also want to ask questions about how the DNA was processed in the sequencing center. But for the most part, this data is good, and you can move to the next step, whether it's trim quality or not. Sometimes, depending on the software you're using, they recommend that you do not trim the reads.
So what does it mean, like cross, read, cross, and write means? What does those means under summary, that left hand side? Like
Ross,
part sequence GC content. This is a cross, means it's not didn't pass or what?
sequence content, is this, oh, this one?
Uh-huh.
It's just showing you, what is this on the left?
Like the value 16,000 something something. What is this? I know like bell shaped curve, that's fine, but how you read this quality? Why it's cross?
You'll have to check on their website. I believe that is the number of reads with that quality.
Okay.
Mean GC and the number of reads. You'll just have to check the FastQC documentation on some of these graphs.
Okay.
All right, so the next step was multi-QC. So select the raw data. The tool type was FastQC. So let's go search for multi-QC right here. What type of tool was used to generate the logs? FastQC. You can start typing in to find it easier. And then, so type of FastQC output, we're just going to select raw data. So click the raw data file, which would be number 9, number 2, number 5. And then click execute. All right, so while that will create a graph like this, and it will show you, if you zoom in, you can see that these are the forward and reverse reads that are up here in the high quality. This is the mean. So the high quality Illumina reads are up top. The min data has a lower quality down here at the bottom. So the next step, while that's running, the next step is assemble with Unicycler. So we're going to search for Unicycler. These are paired in reads. We're going to select the forward and reverse reads, and we're also going to select the long reads, the min data. All right, this is done already. So let's go ahead and look at this. This is the web page. And you can see here is, I don't need that for right now. So you can see it shows you percent duplication within the reads, GC content, average length. And then these are number of reads. Here's the graph you see in the tutorial. Here's some other graphs. Basically all the output from the FastQC is for each sample is merged into one graph. So you can compare multiple samples at once. Okay, so the next step was the assembly using Unicycler. So Unicycler, paired in reads, forward, reverse, min-in reads. So I hid my tool panel, so I'm going to unhide it. Unicycler. Create assemblies with Unicycler. All right, we have paired reads. You can see you have other options here. So the first read, we want to make that a forward read. The second read is going to be the reverse reads. So the history item number 1, remember that was the very first one we had here. History item number 1 is the forward, history item number 2 is reverse. Now the long reads is going to be the number 3. So let's select number 3. And if you wanted, you could run this assembly twice. You could run it without the min-in reads and compare it to the assembly when you do add the long reads. But for this tutorial, we're going to just select the long reads, and I think everything else, use the default parameters. So we'll use the default parameters. You can see you can expand this to select more parameters. In some cases, you may want to change it depending on what type of genome you're assembling. We use the default resources. If you do specify job resources, you can see they have a number of different clusters that the job can be run on. We'll just use the default. And then when you can get an email notification if you want. Right now, I believe it's off. That's on, but it's off now. I don't need an email for this. And then run that. So the assembly is actually what takes time here. That actually may take an hour.
So can you repeat
how long
this,
it
what
took
you
to get
selected for this Unicycler when you have paired reads?
Yes. The third part, the long reads are the min-in reads.
So you have when you select first set reads and then select second set reads. Okay, separately you select here. Okay.
Yeah, I select forward, start out with forward, then reverse, and then basically 1, 2, 3 here.
And
in
what
this
is
case,
that
it's
3? What is that 3?
3 is the min-in reads.
And where did you get this read?
This was downloaded the very first step. When you copy and pasted the 3 data sets.
So you need 3 data sets, or no? I didn't get that. Like when you do paired reads, you get 3 data sets?
Yeah, right here, there's 3 data sets.
We have like short read and long read, is that right? Basically, I think we have the paired Illumina that are short reads, and then we use the mini ion for long reads.
Yes, so see, this is paired. See, there's a little a bracket here. These 2 are the paired reads. This is actually outside of the read pair. So this long read is outside of the read pair.
So you that is optional. You don't need that, right?
Right. You don't need this.
Okay.
But for the tutorial, it's using this. You could run it without it. If you don't have, if you're running your own project and all you have is forward and reverse reads, then that's all you can use.
Okay, good. Thanks.
All right. And in some cases, there are some history items that pop up here that you should not use. So pay attention to what you're selecting here. Like 16 is actually a FastQ file that hasn't even run yet. That's your assembly. So you don't want to use your assembly to do your assembly. So make sure you select the right data set. All right, that is going to be queued for a while. That's okay. We'll go to the next step. We may not have it. Is that what you're doing the analysis on? Okay. let's do this next step, and then we'll take a break, and then I'll install that tool for you. Okay, the next step, Unicycler assembly is going, so we can go ahead and, well, here it says Unicycler takes between 90 minutes and 2 hours. Okay,
Wow.
so that's okay. We can always come back to it later and review the
One
results.
question, like how many sequence you can do like this assembly at a time? Like there is no limitation?
You have to look at the tool. So in this case, paired in reads.
Just one?
You can do a paired collection. So if you have multiple paired in reads,
Suppose
then
I have
you-
like 100.
well, so then you're going to have paired in collections. You have to create a collection of reads. So basically, you can create a collection of reads based on your 100 reads.
So
And you have to find a tutorial on how to create a collection of reads. I think there's actually a tool
okay.
to create a collection of reads.
Because when suppose I have like 96 well played and I got the data from all, and then I want to do all analysis at a time.
The same assembly?
Yeah, means like 96, well, suppose 50 samples, paired samples, like, or 40 paired samples, 80 reads.
Yeah, if all these reads are going to be used for the same assembly,
So I
then
can load at a time. Like I don't want to like do one by one and takes 90 minutes. I want to load all at a time and it will run behind, right?
yes, I believe the way you do that is to create a collection,
Okay.
a paired in collection. But right now there's not a paired collection, so you'll need to create a collection.
Okay.
And I'm really not sure how to create a collection. You'll have to just search the tutorials, see if there's a tutorial on creating a collection.
That's fine. You can go ahead.
Yeah. Okay, the job is still queued, but we're going to go ahead and schedule the next job, which is the assembly, access the assembly quality. So Quast is the tool. You're going to select config scaffold output file. And so let's search for. So you can see it had already selected. It already selected the select the FastA file resulting from the assembly. So this is the FastA final assembly. It already, there's only one here in the history, so it's selected for it. And then config scaffold output file. Genome assembly. We don't have a reference. Okay, this is in the config scaffold file. That's what we're looking for. Config scaffold output file, select the FastA, and that is it. You click run. So we'll leave everything as it is, everything else, and then run that. So you can see when we first uploaded these tools and we tried to run FastQC, it couldn't find the format for these files. I could have assigned them when I was uploading. You can auto assign if you're gonna. You can auto assign FastQ Sanger. To begin with, you can go ahead and assign it as it's being uploaded so that you can actually go to the next step without waiting for these to upload. But we had to wait for them to upload, and then the attribute was updated that it was FastQ Sanger format, and then the FastQ tool recognized it. This tool already knows this. The assembly, the output files are already have an attribute, and that is FastA. So that's why this tool, we're able to run this before this tool even starts. All right.
So
So that's
I have
pretty
one question, like how, so without trimming you are doing, like how it is, like how, why you are doing without trimming, then you have adapters and all the link things, right?
yes,
So,
there's possibility there are adapters there.
so then how it will like align properly, make like contigs with those sequences, extra primer or adapters?
So when you're running it, you're going to get a FASTA file. You're going to get an assembly FASTA file.
Yeah, but before
And
that
then
assembly, you need to
inside
trim.
that file, you can have multiple contigs and scaffolds. And you might actually have, let's just say, for example, you hope to get one contig, which would be the single chromosome for the E. coli. But what happens if you get 5 contigs? You can look at the sizes. So one contig might be the actual size of the genome. So you could say that that is the genome assembly. Then you'll have 4 more other contigs that are shorter. What you could do is you could blast those contigs, parts of the contigs, and see what that data is. It might be contaminant sequence. It might be a plasmid. It might be some assembled part of, for example, the reads that may have had adapter sequence on there. The tool itself may also identify adapter sequence, since a lot of Illumina adapters are provided. I'm not sure exactly the background of the Unicycler tool. You'll have to check into that.
So you don't need to trim, just you just assemble and it will do its job.
In this tutorial, that's what it's doing. You'll definitely want to look at the output of what contigs you get and see what's in the assembly. And you definitely don't want to publish your assembly without looking at all the assembled FASTA contigs. Some of those contigs could be contaminants, could be the FIX, that's the FIX genome that's sometimes spiked into the sequence prep, DNA prep.
Means I was thinking about trimometry anyway.
You can trim, but I would read the Unicycler assembly, Unicycler documentation. They may recommend that you do not trim.
Okay, good. So that I wanted to. I'm not like knowledgeable, but okay, that's good to know. Okay, so
Yeah.
we can directly go there with Unicycle. Okay.
And I know there are some tools that do not want you to trim, such as GATK, when you're doing certain projects. Some of their best practices say do not trim data before you run it through our pipeline.
Okay.
So make sure you read the tutorial or the documentation for the tool you're using.
Or just practice with and without trim and see the result, right? Like play with those. Yeah.
Yeah, especially if it's a bacterial genome. These genomes are assembled very quickly, relatively quickly compared to a human or plant genome. So you can run an assembly. I can go ahead and create a new history, run this assembly with different parameters, and then come back and review them tomorrow or later in the day and compare them. Mm-hmm. And that generally what you want, that's what you're going to do. You're going to create an assembly and you're going to review the assembly, and then you're going to see how you're going to ask, how can I make this assembly better? Check the options that are available in each of the tools. And then you'll also want to do some of this quality output, such as this. Class shows you some quality of the assembly quality output, and just trial and error. You'll run it multiple times and see and compare builds and see which gives you a better build.
Can you also identify like adapter sequence without like asking it, like with FastQ? Like identify, like you don't know like what is that adapter sequence, but you want to know from the sequence. Can you do that here in
Galaxy? If you are running Trimomatic has a file of Illumina adapters. It will use that file. There's other tools like BB Merge or BB Map. BB Map is the name of the tool suite. One of the tools is called BB Merge. That tool, it'll actually search for the adapters. Okay. And it will print out a file of the adapters that are found in your reads. Then you can use that sequence that it prints out as the adapter to do the trimming.
So this is called BB Map.
Yeah, B as in boy, 2 B's, and then map, M-A-P.
Okay, got it. Thank you.
I don't know if there are Galaxy tools for those.
Okay, thank you.
No, not there may be, but it's not on the Galaxy instance. Okay. So now while that's working, I wanted to show you a couple of things. Right now we're viewing one history. If I was to keep working in this history with different projects, you're going to have hundreds of items here, and you can see after a while it's just going to get cluttered, and it's going to be hard to distinguish or find the FASTA files or the assembly results. So you can create a new history. Come back. The button I clicked here is these 2 squares here. This actually shows you to view all histories. So you can see all the histories I've done in the past that are saved. You can see I've already run this tutorial once, and I have all the output here. Actually, there is one more step we need to do, but we'll go over this now. So let's just say I wanted to run this analysis again with the same data set. Okay, so let's just say I do have a new history right here. And instead of copying and pasting and uploading again, I already have the data uploaded. So I can just click and drag this data into this new history. Okay. Now this actually doesn't make a new file, so you don't have this file twice on the file system. It creates a symbolic link to the original data set. So it's like kind of like a link in a browser. You click and it takes you to the original data set. So your data usage doesn't go up. This is better than uploading the files again and running the tutorial again. Especially if you have your data set and you might have one history of just the input files. Then you can click and drag your files to a history where you're doing the analysis. And then you may want to create a new history and then click and drag the input files and then use those same input files for a different type of analysis. This is better than uploading files to your history, creating a new history, and then uploading the same files to a different history. That's just using up extra disk space that you don't need to be using. So this is the new history, the new files. I could run the tutorial again, but I'm going to go back because there is one step we missed. I'm going to switch back to my original one. And then what I didn't do is I didn't name this history. So I'm going to click the name here and I'm going to type in whatever you want, hit enter. That way, later on, when you come back, you don't have a bunch of unnamed histories and you don't know what analysis you did until you have to go browse into each one. All right.
So when I'm searching under your tools like Unicycler, why I'm not getting the options of Unicycler?
Are you on Maroon Galaxy?
No. I'm just use Galaxy.
Maybe you misspelled it. Unicycler.
Unicycler is clear.
Like a unicycle.
Yeah, UNICYCLER.
Is it popping? Do you see it?
Sorry?
Did you find it?
No, I didn't find like mine one.
So are you logged in with an account?
With my account, yeah.
Galaxy?
I can see my history and my other stuff, but not like this Unicycler is not doing anything.
You can go search in the assembly section. So come down here to assembly and then search for Unicycler. I'm not sure why it's not showing up in your browser. Maybe click refresh.
Under what? Assembly?
Assembly.
Oh, first I will search assembly.
Assembly, and then Unicycler's in here somewhere.
Okay, assembly. I got the assembly under, but let's see.
Great, here it is. Create assembly with Unicycler. I'm going to move on to the next step.
Yeah, that's
and
fine.
Then we'll take a break.
Yeah.
Actually, there's one more step I didn't do. That was the annotation. This is just, Quest is just a quality assessment. The next step is annotation. And so what step does is it aligns known proteins to your assembly, and it will create a map of where the genes are located on your assembly. So look for the tool PROKKA, P-R-O-K-K-A. Type of output is Unicycler, contigs annotate. Select the output of Unicycler, genus, species, strain, and use a genus specific database. Yes. So let's. So 16 is the final, is the only option we have in our history. Okay, it said genus. So genus, I'm gonna just copy and paste this. Copy. Genus is this genus. Species, coli, strain C-1. Species, strain. Okay. That's all it's saying. Select the output. Those three. Okay. Use genus specific BLAST database. Use genus specific BLAST database. It's no, so we'll click that to yes. And that's it. Put in the name, select the input, and then that one option. And then we'll go ahead and click run. So you can check this later today. Chances are it'll be done by the end of the day, but it could take longer since the first job hasn't even started, the assembly. And it's all based on how busy the computers are. So we're going to take a break here, and then we'll come back and I'll show you Maroon Galaxy. So we'll take a 10-minute break. We'll be back here at 2:40.
And if I don't have the access in Maroon Galaxy, can you send those PowerPoint like the?
Yeah, I'll show you. I'll give you the link in the
Okay.
in this after the break.
Okay, thank you.
Is there a way of getting a newer mobile version of Maroon Galaxy?
If it's available.
So it's there on public Galaxy, but not on Maroon.
Both that 2 or 1? Both tie or both that 2? Okay, so right now, yeah, there's a newer version available. Oh, I don't even have Bowtie installed. Generally, I install tools as people request them because there's so many.
Yeah.
So I'm going to put this in mapping. So let's install. And then the other one we need is PROKKA. Oh, that's already there. Quest. Okay, let me see. I generally try to match the sections of classes in assembly. So I'm going to install that in assembly. Okay, so that's going to take maybe 5 minutes to install those. Even though it might pop up right away, you can see it's still working in the background. Sometimes as soon as I install it, as soon as I click install, it shows up in the panel, but there's still something going on in the background. So let's wait a little bit before you use those tools. You're welcome.
I actually emailed you yesterday regarding my small RNA data set and not mapping to ribosomal RNA.
Mhm.
I think you replied saying that you found some duplicate names in the file, I guess. Something like that.
Yeah.
So it kind of worked on HiSat. Like I tried using HiSat and it worked, but HiSat does not allow me to create a file for unaligned sequences because I need to then splice them into microRNA mapping or siRNA mapping. So it's kind of working on public galaxies bowtie, but not on maroon galaxies bowtie.
So what it might be is HiSat might allow spaces in the name. So because the first part of your reads would have the exact same, there's a space,
Yeah.
and then it had the coordinates. So what you could do is for the name, paste or append the coordinates at the end. So it has the name and the coordinates, then there's a space.
Oh.
And then the second one is the second part of this RNA, right? The name, the coordinates, which are different. So actually the name of the sequence is different. You could do it that way.
Because then right now I tried running it on the newer version of bowtie on public galaxy and it kind of worked. So that's why I just asked you to install the newer bowtie version on maroon.
Yeah, you also want to check and see, look at the results. It might use just one of those identifiers, maybe the second one. It might use that one to create an index. It might overwrite the first one, or it might use them both and append something on the end. You'll need to just to verify to make sure both of those are getting built, or both of those are being searched. Because some tools may not expect you to have the same read name. Because generally what you do is you have like a genome build or a huge database of non-redundant names, right? Your assembly might be chromosome 1, chromosome 2, chromosome 3. You're generally not going to have chromosome 1 and then chromosome 1 again. You just got to try different things for the names of the FASTA reads, FASTA sequences.
That happens on the server, so I don't need to.
Yeah, it happens on Grace.
On Grid,
Yeah. Okay, so now let's review what we've got here. The assembly is running now. Okay, that can
I
take.
also found my assembly like that tools, so it's assembling. Thank you.
Oh, good. So I think it said it takes about 90 minutes to 2 hours to do the assembly. Maybe that was they're counting the queue time. So Maybe it'll take an hour and a half to do the Unicycler assembly, then the other tools will run. I assume the assembly will be the longest step. This assessment should be pretty quick, but the annotation might take a long time also. So what I've got, I've already done this.
I will ask you one question I have.
Sure. Go ahead.
Oh, the question is like, how can I get the number, like base read or total sequence length from this, like raw data, like FastQ, like total number of
Just search stats,
stats. Okay,
and
from
then
there,
maybe
show.
maybe there's FastA statistics. Maybe there's a FastQ.
Yeah, maybe
I believe in the FastQ output, it also FastQC. It also shows you those stats.
it's okay.
There is normally the insert read and everything you can see from the FastQ report. I think in the first page of the FastQ report.
Let's see.
Yeah, you have the lengths. You have normally you should have also the insert size. Yeah, here.
So sequence
Oh,
length.
That is the min data. Let's look at the. Oh, you see the range, the length.
No, this.
And
So
I
you
think-
actually have more sequences than this shows. FastQC only takes a subset of your data, so you don't have exactly 1 million sequences. It just took a subset to create this. You've actually got more sequences than this. Yeah, so what you'll have to do to get insert size, you'll have to now the min data is insert size because that's one, each one of those is one. Each one of the the third one. This is actually average insert size here because min is just one DNA fragment that's sequenced. But the paired and reads, the insert size you'll have to get from aligning the paired and reads to a genome.
No, I want to know like individual, like read 1, read 2 separately, like how many reads in read 1 and how many like
There might be a FastQ, maybe search FastQ, maybe there's a FastQ stats.
yeah, is a trimmer. Okay, maybe I will play with those and then
Yeah, look around and see if there's a tool to here's FastQ summary statistics by column. So you can do something, here it is, and then it'll show you these columns: min, max, total scores. Actually, that's quality scores. FastQ summaries.
And how you will import those from Galaxy? Can you save in your computer like final assembly or statistics?
How do you download it? So if I wanted to save this, there's a download button here.
Okay, so
you can
anything
download this
like
file.
Like even final assembly or statistics. Yeah, these whatever.
Yeah, in that case, you can probably just view it. You may not need to download it. You may can just copy and paste.
Okay.
If it's just a short output file.
But yeah, but FastA file we can download, right? Final.
Yeah, you can download the assembly when the assembly's done.
Mm-hmm.
Here's the final assembly right here. It's a FastA sequence with 2 sequences. Yeah. The first one is, what is that? 4 million bases. 1x. This is, I don't know what the other contact length would be. So you could search. There's tools here to grep. See. Okay. Search in text files. Let's see. So this is 16. matches Pearl. I'm just going to search for the word length because that should show me the other chromosome here. See length. So what I want to show you while that's running is how to delete files. So it's a two-step process. The first step is to delete the file, which basically hides it from your history. The second step is to delete it permanently. So let's just say I don't need this FastQ data anymore, or any of these. I don't want them in my history anymore. So let's just say I'm going to delete these two files. So delete those. Now notice up here it shows two are deleted. I can click this and it will show me the deleted files. See, there's the deleted files, number 9 and number 8. So right now they're deleted, but they're still saved on the hard disk. So you can either undelete it to move it back to your history, or you can permanently delete it. So if I click this, the files are deleted from the server. You can't get them anymore. Okay, and this is what you want to do when you're done with a lot of files, especially if you're uploading files, input files. This isn't a place to save. Galaxy is not a place to save your input files. It's really a place for analysis. And then when you're done, you download your data.
So do they automatically delete your stuff like after certain memory you use?
You'll have to delete them individually, or if you're done with the history, you can actually delete the whole history.
No, means how much volume we can use like that in the Galaxy, like
In Maroon Galaxy, you have 1 terabyte of data.
And in use Galaxy?
I think it's 500 gigabytes.
Okay.
So let's just say these reads, I don't need these here. We'll undelete these so they'll show back. Now look, there's not any deleted. Okay, so now we're seeing everyone. Let's just say these 3, I don't need them anymore, because I can always go download them because somebody else is saving them on their website. So I don't need to have a copy of these here. So I can delete these 3 and then permanently delete them. But they may not get permanently deleted because remember I made a copy somewhere else. So it's only going to delete the link. But if you do upload FastQ files and permanently delete them, then you can see your file usage here. It would only change, the file usage is only going to change if you permanently delete the files. If you do create symbolic links of your files in multiple histories, you're going to have to go delete them and permanently delete them from all your histories. So it might actually be best to have shared data. It's shared data if you're working with a group. That way multiple users can have access to the same data without having to copy it and use up their quotas. So this is the result. Let's see, what do we see? Here is the assembly gave us 2 contigs. Remember, I ran this tool to search for the word length, and it found the word length. So you have 2 contigs. One is this, basically the circular genome. This is probably a plasmid. You can blast it and see what it hits to. So basically, if you're working, the annotation would be on. Actually, it's probably going to be on both of these. The annotation. You'll have to review the annotation output of PROCA. Okay, so I'm going to go back. Let's go back to the tutorial, and there's the last part that's visualizing the assembly. So that Galaxy has a way to use your local version of IGV. IGV is a genome browser. You can download this and install it on your, for example, this is a Mac laptop. I can install it on this Mac laptop, and then I can launch it on my laptop, and then there's a option to display your assembly in your local IGV. So this will actually load the file into your local IGV that's running on your laptop. I'm not going to do that part, but you can do that and see how it works. So basically what you're going to do is you're going to have the IGV browser, and then you'll load the GFF, which is the coordinates for all the exons. And then this is what you'll see. You'll see all the genes that align to your reference genome or your de novo assembly genome. And if you zoom in, you can see what genes aligned and where they're located. All right. So that's working through one of the tutorials, and you learned a lot about running tools and seeing how they're running on their servers. So we're still going. Okay, so let's go to Maroon Galaxy. So Maroon Galaxy, once you figure out you want to use Galaxy, then if you want to use Maroon Galaxy, you'll need to apply for an HPRC account first, and then once that account is approved, then you can request access to Maroon Galaxy. So let's go to Maroon Galaxy. This is Maroon Galaxy. Okay, the Unicycler and Proca tools are installed, so you can use those now. So our slides have here's the URL for Maroon Galaxy. So once you go there, we have some best practices here. This is a good section to read. We have a link to our slides, which is going to be the slide set we're viewing right now. I'll have to update it, but this is the slides we're showing now. I'm going to have the link right there. And then go back. Okay. So there's the slides, our documentation, which is our wiki. And the Galaxy Wiki has information on how to get an account on Galaxy, the steps you need, request a Maroon Galaxy account. If you decide it's a good choice, get an HPRC account and then request a Maroon Galaxy account. You'll need to use VPN if you're off campus. Here's the link. Okay. There's also a lot of other information here. If there's anything that you need to know specifically for our Galaxy on how to upload data, or some of the tools, like some tools have some options you may need to select when you're running it on our server. Those are described here. Let's see, for example, Trinity. Let's come down to Trinity. Trinity creates a lot of intermediate files, and we've got information here on what to do so that you don't reach your file quota each time you run a Trinity assembly. Okay, let me go back. Okay, let's go back to the slides. So a lot of good information there. Okay, one thing about running your jobs on Maroon Galaxy, it uses Grace. So, and to run a job, you have to have service units. So when you apply for an HPRC account, you will get service units. Basic account is 5,000 service units. That's one CPU for 1 hour for 5,000 hours. Okay, so a lot of these tools, you may end up using 300 service units to do maybe an assembly, for example, or an alignment. And you'll need to check your balance. So we have this, in Maroon Galaxy, we have a tool to check your balance. right here. I can show my balance, show the stats for all my jobs for this fiscal year, or I can change my default account. In order to change your default account, you need to know what your accounts are. If you have a basic account and you have another account of SUs that are allocated to you by your PI, then you may want to change your account if you run out of service units in one of those. That's what you can do right here. You have to input the account number. And you get the account number from here. This is what the output looks like. The account number will be something like this. This first part here. All right, if you're unable to run that tool, most likely you haven't renewed your account. HPRC accounts need to be renewed each fiscal year, and the fiscal year starts on September 1st. There is a grace period, so you may be able to still run jobs on September 1st, but if you haven't renewed it, eventually, like towards the end of September, or the middle of September, you're unable to run jobs. If you're unable to run even this job, then check your account, make sure it's active. You can click on this link, it'll take you to the page to renew it. All right, new Galaxy features. These are only new compared to the old Maroon Galaxy. There's a way to select different software versions. We went through the tutorials, so you click that graduation hat. We have disk quotas set at 1 terabyte, and you're able to see how much space you're using with this. This is your 0% usage, for example, of your quota. If I look at my quota, I'm using 18 gigabytes. I'm using 1% of my quota. And you can add favorites. Click this, add favorites. And basically what this does, then you click this and show your favorites. So this is one of my favorite tools. I use it a lot. I can click this to add to favorites. And then whenever I click this tool, it shows me the ones I use most often. All right, here's another feature that you'll find in Maroon Galaxy, but you won't find at usegalaxy.org. You can actually, the older Galaxy we had running on Ada, you had to select a tool that was already configured to run multiple cores and different dates. So depending on how long you want to run it, you would select one tool that was pre-configured to run 3 days. If you wanted to run more days, you had to switch to a different tool that was pre-configured to run 5 days, for example. Now you can select the number of cores, amount of memory, and how much time you want to run in each tool. So within Galaxy, let's just say I want to run Trinity again. If I run this job again, it's going to select the exact same parameters that were used to create that output file. If I come down here to the bottom, you can see that I used 48 cores. This is pretty much scaled to how many cores you're using. So if you're using 48 cores, that's the whole compute node. So we're going to give you all the memory. So you're basically using the whole compute node for your one job. Okay, which you want to do because you want to take advantage of all the cores and all the memory, because an assembly can take up a lot of memory and it can take advantage of all the cores. I had 24 hours. This job completed in 24 hours. You might want to make it more. Now, in this case, the max is 2 days, and the reason for that is because we have the large memory nodes have a max queue time of 2 days. Okay. Probably we're using 80 cores and 3 terabytes. You're going to get your assembly done within 2 days, hopefully. If not, let us know and we'll change these parameters. Okay, so that is on every tool. Just say some of these tools, like for example, text manipulation. If I want to cut one column, this tool only uses 1 core, so I can't select the number of cores. I can only change the amount of memory. And for text manipulation tools, generally you don't need to use a whole node. You don't need to use 360 gigabytes. You can get by with 7. And 24 is just a good time to keep this the default time for text manipulation should be pretty quick. But for other tools, for example, let's just say text seed. So for this tool, you may want to select, this tool can take advantage of multiple cores. So I may want to use the whole compute node in maybe 3 days, right? And then I can run this, but you obviously need to select your input files. Okay, so that is for tools supporting multi-core. You'll see an option to select multiple cores. If the tool only supports single core processing, you won't see multiple cores, but you'll be able to increase the amount of memory and time. And this is for the large memory nodes. That's the one I showed you in Trinity. You can select 80 cores and 3 terabytes of memory. And those are configured for tools that actually may use 1 terabyte or 2 terabytes of memory. You won't see it in the text manipulation tools. All right, this is kind of what's on the wiki. Check out usegalaxy.org. If you like it, you can request an account on Maroon Galaxy. You've got some links here. And there's no backup to these files. All right, let's just say you want to use the tool. The first place to look is search here. BBMap. We don't have BBMap on Galaxy. So let's go to usegalaxy.org. BBMap, it's not there either. So there's a tool shed here. Let's go to this tool shed. Let me go back. Let's find it. Open a new tab. Okay. Tool shed. There may not be a tool for BB. Okay, somebody's written a tool for BBMap. First thing you want to do is check the date. If the tool was created in 1999, it probably doesn't go back that far, but if it's already 10 years old, chances are the tool hasn't been updated, and I would recommend you not to use it. The tools need to stay, these Galaxy tools need to stay current with the actual background tool. For example, BBMap. Not sure which version this tool is using, but we didn't find it on Maroon Galaxy and we didn't find it on Used Galaxy, but it is available in the tool shed. So I can, as an admin, I can come here and I can install it directly from the tool shed. Another thing you want to check is who creates it, who's the owner. IUC, that is one of the main Galaxy teams groups. I think they call themselves Intergalactic User something or another. I forget what IUC stands for. IUC is the Galaxy team. Let's see what this. Okay, they have a. So this is a good trusted owner. Anyone can put tools on Toolshed, but you want to. One thing is maintaining the tools. That's continued work, and this group continues to maintain their tools. So I could install this if you wanted. I can install it and place it in one of these categories if someone requests.
So BBMap is not available normally in Galaxy, right?
Right. Look how many tools there are available, 8,000 tools. So if you install Galaxy, you don't need to have all 8,000 tools installed. You just install them as you need them. Mm-hmm. There are some default tools when you first install Galaxy, but for the most part, you can do a lot of things with Galaxy besides run bioinformatics analysis. You can do machine learning. You can create your own tools to manage, for example, manage your lab purchasing products, create a purchasing app for your lab maintenance. You can do whatever you want. So that's why all these tools aren't installed. And even though there's 8,440 tools, each one of these tools can have several versions. So you can see there's a big community support for Galaxy. And if you have any problems with any of these tools, you'll just need to contact the person who developed the tool.
And why we are not using like bow tie there, like for assembly or something, like for quick assembly or alignment?
Yeah, you can use bow tie. It depends on what you want to use.
Like, can we do like the contic preparation in bow tie instead of like normal Galaxy assembly?
You can do it on the command line, yeah.
And that will be faster, right? Because this seems like that I
Uh,
was like googling it and it shows like it's a very fast tools.
Well, it depends on how quick you are with a mouse compared to a keyboard. If I was going to do an alignment, I just need a reference and I need the sequences, and then I click bow tie and then select what I want and click run. But on the command line, you have to load the module, you have to see what the commands are, you have to create a job script and then submit the job script. So it depends on what you're most comfortable with. Okay, let's talk about uploading files to Galaxy. So you can upload with the upload data here. So these are the upload data file. The upload data button uses an HTTP protocol. So that protocol is designed for files less than 2 gigabytes. So if you have a file that's 8 gigabytes, you don't want to use that protocol because it could lose connection and not complete, and then you have to start over. So anything less than 2 gigabytes, this is the way to upload it. You can also retrieve data directly from websites like UCSC. So if we come here, get data, you can go to the UCSC main. And then let's just say I wanted to get something from virus, Ebola, yeah, let's see, SARS, let's do. And then let's just say get output. We'll just do the whole genome, get output. Now, once you select whatever you want, let's just say you want the exons, then you say send query to Galaxy. And what this is going to do, I'll just go ahead and do it. It's actually going to come back to your Galaxy, and you may have to refresh the page. And then it should import it here. And then let's see. Okay, these are the steps. This is what we did earlier. We clicked the upload, we click fetch data, paste or fetch. We pasted the URL and click start, and it uploads. If your files are larger than 2 gigabytes, you'll need to use a different tool to upload files to Galaxy. So you can either use, if you're using Mac or Linux, you can use terminal and use the SFTP command. If you're using Windows, I recommend installing this Bitvice on your Windows computer. And then if you go to this, open that new tab. So on our wiki, it shows you what command to use. And depending on whether you're using Grace, you'll use port 2121. So SFTP, the port number, your net ID, and then everything else here. So the only thing you need to change is your net ID. You have an FTP directory that's already configured. So once you log in, you'll see a prompt like this. Then you just say put file name. You can type in ls and you can see the files. You can type in exit.
So from Mac is possible, not from Windows.
It's possible from Windows if you install this Bitvice, but for Mac and Linux, you can use the terminal. And the reason I recommend Bitvice is because we have an dual authentication enabled, and so Bitvice works better than FileZilla or Mobex Term. If you're on Grace, if you're working on the command line and want to run something in Galaxy, you can copy it from Grace to the FTP directory. Just use SFTP on Grace. After you've finished copying the files, go to upload file and look for it. Let's see. I don't think I have any because, okay, choose FTP files. So once I upload an FTP file, it's going to show up right here. And then I'm able to select it and click start. But I don't have any here. These files are deleted after they've been there for 2 days. I'm going to change that to 3 days in case you upload on a Friday, you'll be able to import it on a Monday. But once you get through with either Bitvice or the terminal, this is where you find the file.
Can I ask a quick question?
Sure.
So on campus sequencing facility, they have a couple of places that they upload the sequencing result for the samples we submit. One is like a vet school facility upload the sequence into the Google Drive and share that link to us. So what is the best practice to move those files from those shared Google Drive to Maroon Galaxy?
So if it's, you might can use this paste here. If the file has a URL and it doesn't require password to access, you can paste it here. Like if your files are shared.
Even it is a multiple files?
Yes, you can paste several URLs here.
I don't know if the Google Drive gives the specific address to individual files.
Yeah, you may have to download them locally and then upload them into Galaxy.
So that would be transferring 2 times, right?
Right.
So there's no shortcut for that to directly connecting to it.
The only shortcut I can think of is if you're able to get a link to the Google file.
Okay. All right, thank you.
But chances are, since you have to log into Google, it uses your Google credentials to access the file. Chances are you're not going to be able to paste it here because Galaxy's not linked to your. Well, it might be because A&M does actually have Google accounts. I'm not sure. You can try that. Try that. If you can find a URL for the file, paste it in here and see if it works.
Mm.
So I have a question like then what about the 2 GB that option if you load more than that in that link?
Okay, so you'll want to use this, either the terminal or Bitvice.
Then you can
Bitvice is just a GUI you install on, let me go down to Bitvice. So Bitvice is just a GUI interface that you install on your desktop, and it allows you to upload files, connect to the Grace and upload them to the FTP directory. So these are for large files. Then you'll import them this way once they're uploaded. From your FTP directory, they'll be deleted in 48 hours. I'm going to change this to 72, but you'll need to import. So even though they're on your FTP directory, you haven't imported them yet. So you need to go here and import them into your history. And then once they're imported, then you have them in your Galaxy history to use. Now, if you have a file that's greater than 2 GB and it is on a FTP server, you can paste the FTP URL here. See that actually, this may not be an exactly FTP protocol because it starts out with HTTP, but you can paste the FTP URL in here for large files. That's another way, because it's going to be doing that in the background, connected via FTP to the FTP site.
And if I need to upload my sequences in FTP link, so I can go through Windows using Bitvice, right?
No, if you have an FTP server is basically like Ensemble. They have a FTP server. So it has a URL to the file, and you can download that. You can just paste
No,
that in
like
here. It
suppose
uses the
suppose
FTP protocol.
I'm working with a group and they have created a FTP link, and then I need to upload my data there. How I will do it from Windows?
To upload your data, you mean to download the data from the FTP link to Galaxy?
No. Sending my data to that folder, FTP link.
This you can't send it to their FTP using this tool. You can only download it from the
Not from
Maroon
their,
Galaxy
from
FTP.
my computer. Suppose I have Windows. Can I do that, or I need Mac or Unix? Or that.
So you have a Windows computer and you have your files on your computer, and you want to upload them where?
That in FTP link.
You want to upload them to Maroon Galaxy?
Not Maroon Galaxy, to a server.
Then you can't use Galaxy to upload them to a remote FTP site. You can only upload to our FTP directory this way. This is actually downloading from an FTP to Galaxy. If you want to upload your files using FTP, then you have to use Bitvice.
Got it. Thank you.
Select the SFTP protocol on Bitvice. Okay, copy data between histories. We went over that. Just click and drag. You can't click in the current history and drag it to a different history. You have to click from a different history, click it and drag it to the current history. That was how to view all histories. Then you will see the data usage doesn't change because you're only creating a link to the data. You're not actually copying the data. All right. So when you upload files, you can upload files and they will stay in the gzip format. So the earlier version of Galaxy would unzip the files. And it would unzip them, and then they would be in Galaxy as FastQ. So in order to save disk space, Galaxy now preserves it in the same format as you upload it. Some tools will accept the gzip format, some tools will not. If a tool does not accept gzip format, then you'll need to uncompress the file, the input file, and then use that as the tool input. So now if you uncompress it, you've got 2 copies of the same data. So you need to delete one of these. Best thing to do is probably when you're done with the analysis to delete the uncompressed, and so you have the compressed file. Then if you need to continue working, you can always uncompress it later. But if you're done with the project, then the best thing to do is just delete these 2 files, because you should have this data saved locally somewhere instead of on our Galaxy, because these files on Galaxy are not backed up and you do have a quota. So this shows you how to convert format. Click this pencil icon. So for any of these, you have an attribute icon, click that. Second step is to click convert, and then find convert, and then find, there's actually no options for this type of data. But if I was to have a GZ format tool, here's this. I've got a GZ format tool, convert. I want to convert compressed to uncompressed. So when I click convert data type, it's going to create a new file up here on top of the uncompressed data, which I can use if a tool requires it to be uncompressed. All right, permanently delete non-essential files. We went over that. First, you have to delete it with the X, show you're deleted, permanently delete it, and then your usage will go down. You can also, right now there's a bug in the Maroon Galaxy where you can't permanently delete individual files. You have to go through a second step. So for example, I'm deleting these files here that are failed. I'm going to 12 deleted. I'm going to permanently delete this, but it actually looks like it's working today. Okay, it's working. So if it didn't work, you would have to do this. You would have to click the gear icon, click purge deleted data sets. So actually you saw that I was deleting one file at a time like this. Okay, instead of doing one at a time, you can purge deleted data sets and you can delete them all at once. Okay. Then again, once they're permanently deleted, they're gone. All right. The old Galaxy version we had did not automatically detect file type, but the new Galaxy will automatically detect whether it's FastQ or FastQ Sanger. All the new Illumina sequence machines have FastQ Sanger file type. That's based on the quality scores. You can also see the encoding type. If you run FastQC, it'll show you the Illumina, whether it's Illumina 1.8 higher. In this case, it's 1.9, so that is FastQ Sanger format. That's the encoding. That's this fourth row here for the sequence here. That's just a way to translate these single characters into two characters. So for example, this quality score is for this nucleotide. C might actually be a 30. So instead of using 2 digits, we can use a single digit. So that way your quality score is the same length as the sequence. History divider, this is a tool we only have on our Galaxy. Basically what it does, you run it and it will put lines between your runs of your tools. So you can see I ran Trinity and then I ran the divider and I ran Trinity again. If I didn't create the divider, then you can see, then what happens is all these, you just got a history, all your histories seem to run together. You can't tell which output without quickly seeing, can't tell exactly how many files were output with this job. So that's why I have these. So then it's easier to see that this Trinity run created 2 output files. Keep it separate from this other Trinity run. That's what that is for. Shared data libraries, we do have some shared data libraries. You can check right now. We've just got some example data and some example genome builds. If you want to have some data shared with your group, you can let us know and we'll add it. Okay, failed jobs, failed to queue job. Make sure you have enough service units. Again, use this tool, service unit balance. And if that tool doesn't run, chances are you need to renew your HPRC account. And if you do have enough SUs in your job still not queuing, let us know. Sometimes the scheduler is slow and the job doesn't queue properly, doesn't return the correct code. So your job, it may be due to the Slurm scheduler. Check this little area here. Right when if your tool fails, check this little area and it will give you some information. For example, what do we see here? Click on that and you can expand that to see this area here, or better yet, it might be a short message like this, and then basically it ran longer than the max allowed runtime. So all you need to do is, if it was default 24, make it 72. Make it a longer runtime. Or if you didn't configure enough memory, the job failed because it used more memory than was allocated. If you used 28 cores, on Grace, you can select 48 cores. Or if it's just a tool where you can only select memory and you used 5, make it 10. All right, check the log files. There's different ways to view the log files. This little error message that we just talked about, if you click this bug button here, it will give you some more information. So click the bug button It doesn't give you much here, fatal error. Sometimes this will give you the information you need. View details. Now you got these two boxes. This is the standard error here. This is a standard out. So check these two boxes. It can be pretty long, but read through all this because chances are in that log file, somewhere in there, it's going to be, you're going to see a message that tells you why the job failed. And if you send me a message saying, I can't figure out why this failed, as long as your service units are good and everything ran, if you didn't run out of time or didn't run out of memory, then I'm going to have to, I'll basically look at the same log files you're looking at. But sometimes these tools, they just don't work, even though they work on some, they work on usegalaxy.org, they may not work on ours because we run our tools on a cluster, and UseGalaxy, the main site is not on a cluster. And so there may be some issues with running on the cluster as the actual user. If you have any problems, let us know which Galaxy you're using. We do have more than one. We have a silver Galaxy on Terra. That's kind of like an intermediate Galaxy when Ada was being retired. But everyone, it's better to use Maroon Galaxy because Grace has more memory and more cores for each compute node. Tell us the history name. In this case, it's stacks 2. Which item number? In this case, it's item 24. That way I can come and look at these log files and I might be familiar with this error and I can get back to you quickly, or it might take some time updating the tool, going into the actual, into the tool on the Grace file system and changing something in the tool to make it work, which I've had to do that before. All right. Also, what I've seen is sometimes you need to refresh the browser because something's not showing up properly. Your history disappeared. If you leave this idle for a while, this history could just disappear. So you have to click refresh here. And then if your history's still gone, you can refresh the history here. So that may be the case. Like if this download button, if you want to download this, it's not showing up, just refresh the browser and it'll show up. In this case, it's here. All right, that's it. So this is just a information for contacting us if you have any problems. And just remember to let us know which Maroon Galaxy you're using and history name and the item number, and I can check it. And also let us know when the issue's been resolved so we can close the ticket. All right, so if anyone has any questions, we'll hang out for a little bit and answer questions.
I have one question.
Go ahead.
Can we explain the statistical analysis of quality report? FastQC report.
Okay, well, I think I skipped this slide. I'll go to that in just a second. Just remember, your HPRC Galaxy is the same as your TMU net ID and password, so don't share your Galaxy account. Okay, FastQC output. So we have another course we had. So it is the intro to HPRC. And we talked about, that's not it. Intro to next generation sequencing. So click the files there. And then we have a few slides on FastQC. So this graph is basically showing you the distribution of all the, or a subsample of your data at position 1. So basically, this first quality score, this is the average showing you the upper quartile, the median, and lower. So a fourth of your data is here, a fourth of your data is here, a fourth here, and a fourth here. This is the median, not the mean. The mean is this blue line here. So this is good. I've actually chopped off the yellow and red, but towards the end with these long reads, you're going to see data get into the lower quality, which again, see if the tool, the next analysis tool requires trimming or not. If you have short reads like 100 bases, chances are that the entire read is really good quality.
Okay.
And then this starts to bend several quality scores. It takes an average and gives you the plot. You can expand this per base, but to get it done quicker, it does an average. This is the one I told you about where even though it looks bad and it failed the quality control, it's not actually failing. This is a transposase that was used to cleave the DNA. And this is a motif that the transposase recognizes.
So that's
So
why
this is actually your DNA
but
sequence.
rest is chopped, right? The straight lines are chopped.
This,
Like,
your double-stranded DNA, the whole genome DNA was cleaved by the transposase into smaller fragments. And the very first part of this fragment has a high T, and T is the red, A is the green, so it has a high percent of those two nucleotides compared to G and C. So that's why it looks, you can see there's kind of a pattern here. It is almost
so which one
symmetrical
is
here.
good? Like these peaks are good, or the straight line means I want to understand the image.
Okay, so this is 30% A, 30% T, right? Because A and T.
So is
A
there any
binds to
link
T.
between like the straight line versus like peaks?
Right. So what would you expect? You expect A and T to be the exact same, right? And G and C you would expect to be the same. So this is 30. So 30 for A, 30 for T, that's 60%. 20 for G, 20 for C, that's 40%. So 100%, these adds up to 100%. So you got 30%, you got basically 20% GC content is what you have here.
Mhm.
But across the entire read length, at the beginning, it's not that. That's why this looks weird.
Okay.
That doesn't mean it's bad quality data. It actually means you need to investigate this more.
Mhm.
Yeah, ideally you would want to have this a straight line for T, the red and the green, and then G and C, the blue and the black. It's failed. FastQC failed it because of this. But I know based on how this DNA was prepped, this is a transposase motif. The motif that's recognized by the transposase. And you'll also see this also in like K-mer profiles. You'll see this, you'll want to see this flat, but you've got all these K-mers. K-mer is just a string of characters that's found it's found sequentially. You'll see this string over and over, and that's at the beginning. So even though FastQC said it failed, you need to review the images.
And what is this?
So this is the flow cell. This is the flow cell. You can go through these slides and you can see all of this. It shows you some failed examples, and basically you'll need to review your output files and also review the information that's provided by the FastQC tool.
I will go through these slides sometime. Okay, thank you.
All right, any other questions? Oh, one thing I actually didn't show you, one more thing I need to show you, that's a workflow. So this is a Maroon Galaxy. Let me go back to the, oh, I need to go to Use Galaxy. Use Galaxy. let's just say I'm going to switch to this. Okay, let's just say I want to save this workflow so that I don't have to configure all these tools again in the future. So what I can do is I can select extract workflow. All right, so I'm going to extract workflow and I'm going to keep it this name here. And basically you can see it has all the tools lined up and configured. So next time, all you need to do is input your data from your next sample, okay? So I'm gonna create the workflow. All right, it's already created. So let's start a new history. Actually, let me come back here. Create a new history. Now I have a new history. Now down here at the bottom, there's the workflows. Now I've got the workflow here. I'm gonna run this workflow. You know, let me go back and select the history where this history here where I have the input files. Let's just say this is my second sample and I want to run my workflow that I created from the other history. Run your workflow. You see I did this 4 days ago, same workflow. Now it's got all the tools lined up. All I need to do is fill in this part. Forward read, reverse read, and min-in read. Now I've already got everything else is already configured. The same parameters and options I had in the previous run. So now all I need to do is click run the workflow. And basically it's going to reproduce the workflow that I did in this first in the tutorial that we just went over. And that will fill up, see, I already populated all the jobs that I went through individually. Now I don't have to go through for my next sample.
So like means from upload, after upload means all the assembly, then whatever like quality score, everything will be done automatically, right? You don't have to do anything.
Right, everything's configured based on what you've already configured a previous history.
And just it will take the same time, like after 3 hours or 4 hours, you can get this data, right?
Probably, you know, it might be queued quicker. It might not take as long to queue the assembly. Mm-hmm. This assembly has to wait. Actually, I don't think it has to wait on this. This is just waiting on the queue. So, yeah, right now the queue might only take you 5 minutes instead of an hour before your job starts. So the time to complete might be quicker or it might be longer, just depending on how busy the cluster is.
And I will
or how busy usegalaxy.org is.
Collection of reads, maybe that will be helpful for me. Okay. Or if you can figure out, that will be great, and communicate like how to do that collection of reads, like 50 reads at a time, analyzing.
And then you might want to put history to remind yourself that you used a workflow for this. That's it. So then when you look at all your histories, this is the first one I did. Oh, this is the one I did. E. coli assembly tutorial, it's still running. So is this one. Oh, this one's on multi-QC. So multi-QC doesn't need to wait until the assembly's finished because it's actually running on these files over here. These are done. There's another way to view histories. Click user histories, and you can see, you can get kind of a table of your histories here. You can switch to the history or just view usage and Yes, you can purge the history if you're done. Right now, I could purge this history. Purge. Well, maybe it's here. One of these you can purge, delete permanently. So if I want to delete this history, even though it's running, oh, here's one here, unnamed, I don't need this, delete permanently. Sure, it's gone. I thought there would be one, purge history. I guess not. I guess you do have to come here to delete the history. Now remember, you asked about exporting history. Here's the import history button. So user histories, import that history file that you downloaded, you're exported. Okay, any more questions?
So after assembly, I can see like it's just the data is not showing, nothing is visible, although it's showing green means it's done. It shows 0 bytes. What may be the reason?
Check your input files, make sure you have data in your input files, and then refresh the browser. You might have to refresh the browser for it to update, or it might be taking a minute to update.
Okay, I will check that. Okay.
See if my first one's done. No, my first one's still running. Yeah, refresh the browser. Refresh the browser, try again. There's another feature I can show you. One more thing. This scratchbook. So you click the scratchbook to enable it. And then what this does is when you want to view a file, this data file, and you view it, it pops up in a window here. So that way it's not in this middle panel, and it might make it easier to copy and paste. I don't know what. Okay, Control A, copy, paste, or it might make it easier to browse. You can have multiple. You can have multiple showing up. Let's see. Yeah, here's 2 of them. So if you want to compare two results files, you can use this scratchbook. Okay, and then you can close them. All right, and disable the scratchbook. And as with Galaxy, Maroon Galaxy, make sure you log off when you're done. Log out, and then log off of the system and close your browser, especially if you're working in a lab on campus. I'm not going to log out though. Okay. So I also put announcements here when we have a maintenance, when there's a grace maintenance, Galaxy will be down also. So check this message here. We have a maintenance next week. Actually, this is a 2-day maintenance, 28th and 29th. So if you schedule a job to run for 12 days, it's not going to run because the maintenance is only a few days away. There are some known issues. Actually, the purge deleted data set seems to be working now. Sometimes the tool, the history, if it has the name of the file, if it has a parentheses in it, and you try to run it in another tool, it can fail. That's something some other user ran into. You can watch these videos directly here.
I have
This is not me.
several
This is
data
someone else.
sets accessible from the web, so they have URL.
This is the Galaxy team. Okay, any more questions? Okay, actually one more thing I need to say. I haven't configured this yet, but whenever you click this bug, it actually shows you that you can send a report. I don't have this configured yet, so don't use this yet. and just send an email to the help desk. All right, if that's it, then we'll go ahead and finish up for today. And thank you for attending, and everyone have a good weekend.
Thank you.